So set up your unit page. The name of the unit is percent. Once you set up your unit page, you can set up your lesson 7.1 page. Which is entitled everybody's favorite, Fractions and Percents.
Finally, since we have if we have a test on percentage, it's going to be easy.
That's what you said about proportions.
I mean, the proportion part was easy, but completely blanked out.
The unit conversion was just proportions. Still proportions. Everything on that test were proportions.
Gallons to whatever it was.
You can use the book. I told you.
The book didn't have everything.
You are a liar, sir. You are a liar. Liar, liar, liar. There was one that you may have had to take 2 jumps to get there. But you had everything you need.
I have to take like 3 jumps. All of them.
I figured maybe you didn't do any jumps at all.
No, I took like 3 jumps. Most of them. Or tried to.
This chapter is still so hard to figure out.
What?
Tell us to get.
TI 32 line or the TI 30, I don't remember, 34. Those Casios are good too. They're good calculators. They're great. Yeah. For this class, all you're ever going to need is multiply, divide, add, subtract. So you're definitely good to go. All right, I'll give you all half a second to set up your unit page. Okay. So here we go. Y'all ready? Fractions and percents. This should, theoretically, at least the first bits anyway, be kind of review for you. And so we're going to jump straight into example. Not review from this class, but review from previous, theoretically. And so we're gonna jump straight in.
Wasn't I learning this when I jumped over to this class?
Heck if I know. Write each percent as a fraction in simplest form.
Mr. Sean,
Yes, sir.
am I allowed to use the reducing feature on my calculator?
Yes,
Okay. I didn't know. There's a reducing feature?
kind of.
On certain ones, yeah.
Yours will do it. It'll automatically give you the most reduced.
Mine doesn't. Who makes that?
Yes, it does.
I have to hit a button.
Lies. Lies. You had to push enter. Okay, so example number 1. First one we're going to start off with is easy, 60%. So to convert 60% to a fraction, what do we do? Somebody knows. I know somebody does.
Sorry, say that again?
1 over 10.
To convert 60% to a fraction, how do we do it?
So it says
60 over 100.
Thank you. That's what I'm looking for right there. 60 over 100. We should probably reduce the thing, right? So to start reducing, remember that a really easy way to start is if we end in zeros, we can just go whap and kill the zeros, right? Some of them, the ones that match, right? So what goes into 6 and 10? 2. So divide top and bottom by 2, which equals 3/5. It's perfecto. Easy peasy, lemon squeezy. Okay. Next one. It's not quite so easy, but close. Number 2. 12.5%. So
What did that mean? 12? Yeah, 12.5.
it would be. Why do we care about that?
It's easier for my brain, so.
You could if you want to be a baby about it. You tired over there? Your eyes look tired.
So do you convert this to a decimal and then put it over 100?
I wouldn't convert it to a decimal. I'd just put it over 100. That's what I'd do if it were me. Me, I'd just write the answer. So because I want you to use your big brains without converting anything to a decimal, what's a way we could get to the answer, to the simplified answer? Instead of converting that to a decimal, what could we convert it to? Yeah, improper fraction, yes. So we multiply and add, right? So it ends up being what when we convert it to an improper fraction?
25/2.
It is 25/2.
Wait.
Because you multiply 2 times 12 and then add 1, right? I don't know how they took a perfectly decent program and broke basically everything about it. Even the colors are stupid.
Are there
Dumb.
only certain colors now?
No, they're just slightly different. And they're uglier.
After the last update, I stopped using it.
So 25/2.
It's still, for me, as long as the internet is vaguely decent, still the easiest program. When I upgrade my RAM, which hopefully should come in today, then probably I can use Photoshop and move on with my life, but it'll be great. What is divided by 100 the same as? Same as multiplying times what?
0.1 or 0.0.
I said we're not converting to a decimal. 1/100, right? So we could rewrite this problem as 25 halves times 1/100. This is not the only way to solve this problem, by the way. This way just lets you do it all in your head, and then you don't even need your stinking calculator. Because we can pre-reduce, right? What goes into 25 and 100? 25 does, which gives us 4 when we divide, which is probably what you meant. 25 divided by 25 is 1, right? 100 divided by 25 is 4. So this equals 2 times 4. So 1/8. You could also, if you wanted, here's my fear right now, which is why I'm pushing you to do it this way, because I've seen it happen lots. And if I start to see it happen, then we're just going to course correct because I have control, because I'm teaching the middle school and pre-algebra classes, both of those. Okay, and so I get to head it off in the pass if I see the problem happening. Because you could also put 12.5 divided by 100, enter in your calculator. right? The problem is none of you, literally none of you in this room needed a calculator to solve this problem. None of you did. Every one of you could do those steps that we did. And what happens a lot of times is at wherever it happens, whether it's 8th grade or 9th grade or freshman, sophomore, whatever. I said the same thing twice, but you get it. People start just using the calculator and they forget how to do math. And I don't want you to do that because it's going to make stuff a lot easier for you later. Because if you can do math, then it makes when you go later in your career, stupid program, I hate you, and you're doing stuff like this, if this will open fast enough to not be obnoxious, then we'll look at it. If you can do math, then you remember how to do math, then you can do all of this ugly crap, and it's not as hard as it looks. But if you get to where you're just relying on the calculator to think for you, then this ugly stuff gets a lot harder, because this you can't do a calculator. In fact, on the test that gives this problem would be on a section that said you may not use a calculator on these problems. So, if I am debating about whether ultimately this lesson is going to be allowed to use a calculator on the test, the answer may be no. For now, it's yes, but I want to see how y'all do using it. Because I want you, while you use the calculator, to remember how to math. Does that make sense, sort of, to everybody? This is not yelling. I just am trying to head things off at the pass early.
You don't have to worry about me because I have no idea.
I figured that you were not one of the ones I was worried about. You usually push yourself to do it the other way anyway, which is great. And I think most of y'all will do the same. So I think we're going to be fine. I think we're going to be allowed to use a calculator on this test, but we will see.
So we should practice all of it without.
Oh, always. That's always true. You should always do that. All right, let's do a couple GPs. Guided practices, which means I'm going to freeze the screen and you're going to YOLO it. Well, GP number 1, guided practice. 40%. And since these are fairly straightforward, that one at least is fairly straightforward, GP number 2 is going to be 20 3/4%. Go. So there's where we should have ended up. 2/5.
Oh,
I tried to reduce 83.
yeah, I tried to. I tried to do it too, and I was like still going. I was like, well, whatever.
I didn't get
It doesn't reduce. It does not. Any questions on those two? Yep, 83 over 400 doesn't even reduce. It's just kind of ugly.
I can reduce it.
You could? Is that what you said?
I said tried to reduce it.
Oh, yeah.
No, I was working on it.
I think, and I could be wrong, I'm not super great at larger prime numbers, but I think 83 is probably prime, and it doesn't go into 400.
Yeah, it is. Because it won't divide that.
Yeah. Did you try them all?
I tried, well, I tried like really low numbers too. Like I tried like, it just wasn't gonna.
Wasn't going to happen. Okay. Let's do a couple other examples.
What is it?
Let's do a couple other examples. Example number 3. Is 0.8%. Okay. So to convert, the instructions are still the same. We'll do it the other way around here in a minute. And we are not going to do it the way they do it in the book because that's stupid. So the steps are the same. You don't have to raise your hand. What?
At the final answer, would we add like a decimal or something like that?
If you need to. So, no, we want it. No. I had to think. I had to stop and think. No, because we are going to. The instructions are the same, so we need to write this as a fraction. So you would not add a decimal because we want this as a fraction. So the steps are the same. We write this as 0.8 over 100. Dividing and multiplying by powers of 10 is super simple. How do you do that? Move the decimal that many places. So how many places are we going to move the decimal? Twice. We're expecting a smaller number, right? You know, oh, mother of pearls. Yeah, that's true if we're trying to get a decimal as an answer. Sorry, sometimes I have to make a confused face because I have to figure out how to not confuse y'all. It doesn't always work.
I am very grateful if you don't confuse us.
I never try. No, because that's, well, yeah, that would be an answer. That was because that's a decimal. So when we're converting a decimal to when we're converting a decimal divided by a number to a fraction, or just a decimal to a fraction, we just divide, long division, right? So I think that's the route we're going to go instead of converting twice. And we're going to do 100 into 0.8. Sorry, I really, there's several layers of things. I'm trying to decide how many words to say, because the more words I say, the more likely you're confused.
How about you say it the complicated way first?
No, how about not? How about you let me teach, man? I know how to teach. Dang it. We'll start with this plan. All right. 100 doesn't go into either of these. We got to add zeros. Right? We're going to go in 8 times right here, right? 8 times 100 is 800. And then we're going to subtract. Equals 0. So our answer is 8 over 100.
So would you not float the decimal?
Oh, you would float. This is not helpful. Okay, so we do have to say more words. I'm sorry. I was trying to do things, and no matter what I'm doing, we're just keeping it a decimal. Sorry. We need this to not be a decimal and a fraction. So how can we get rid of the decimal on top? We could just erase it, which would be strange magic and not going to help, but a good idea. Not quite. So I can move this decimal place over once if I move this decimal place over once. Then you have 8 over 1,000.
So we don't need any of the dividing?
Well, we're going to divide in a minute because we're going to reduce this fraction.
I mean the dividing we just did.
We don't need any of the dividing we just did. Does that make sense? to everybody what we just did. I was afraid of saying this because I was afraid it's going to be confusing, so I want to make sure that it's not confusing. Everybody get what we just did? Okay, we'll be able to repeat it in the future. Now we need to reduce that thing. What is this going to reduce by?
8.
Sure. What's 8 divided by 8? What's 1,000 divided by 8?
125.
It is 125. 1 over 125 is, in fact, the answer. Does that make sense to everybody? Even though it took a long time to get there? Because I had to stop and think too much. Okay.
Why did we write -8?
I'm not going to dignify that stupid question with a response. What do you think that is, buddy? What do you think that is? Why would we put minus? Use your brain before you ask. Use your head before you ask the obnoxious question. Listen to the word. I didn't say see it. I said use your head before you ask the obnoxious question. Make some assumptions based on facts that you know, like that we probably divided. Because you know that, don't you? Yeah, I thought so. We're going to do a fourth example, and then we're going to do a couple more GPs.
Group practices.
175%. Steps are the same. So what am I going to do first? 175 over 100. Because we always put it over 100 whenever we're doing percent to fraction. Always. Okay. Now, we don't want to leave that as an improper fraction. So to convert a improper fraction to a, to a mixed number, what are we going to do? Divide it. 100 divided into 175. If you're fairly familiar with really simple things like quarters and all that kind of stuff, you may have already figured out the answer, which is fine. But in the likely eventuality that that's not the case, let's walk it through the long way. 100 goes into 175 how many times? Once. 1 times 100 is 100. 175 minus 100 is how many? 75. 1 and, no, not decimal. We're converting to a fraction. 1 and 75 over 100. 75 over 100 reduces by?
3/4.
It reduces to 3/4. What are we reducing by? With my little division symbol. Stop it. Stop it. No, you don't. Stop it. Yes, you do. Actually, what are we dividing by? 4 doesn't go into 75. What goes into 75 and 100? 25. There we go. There we go. Start the game already. Gold, please. 1 3/4. I told you probably already got the answer, which you did. Good job. So proud, Noah. And Nathan, I think he already had the answer. Possibly more of you, but they were loud about it. Okay. Let's do a couple of GPs. Guided practice number 3. Is 0.2%, 0.2%. And GP number 4 is 150%. Yes, Nathan, you should show your work. No, it's not. No, it's not. I know that number 4 is theoretically not very hard at all. Actually, 3 is probably easier than that other one too. It's not terrible. But get her done. Get her done. One of the worst comedians in the industry. Okay. There's where we should have ended up.
I didn't even start the next one yet. Number 3.
Okay. Why not? Because you were talking.
Oh, because I'm slow.
That may be part of it, but that's not all of it.
Second one wrong. I got both of them somehow correct.
Okay, where did we make mistakes?
I thought you got them right.
Did you figure it out? The second one you said?
Yes, I got everything right up until.
Did you get like 25 over 50 or
I got 1 and 2/3.
2/3? Did you get 50 here?
Yeah.
And 50 over 100?
Oh, yeah. I see what you mean.
I don't know what you divided.
I divided by 5 the first time.
So that would have been 10 over 20, yes.
Then I did divided by 5 again.
So that would have been 5 over what did we say, 20? 5 over, what are we doing, 10? So it'd be 2 over 4.
Oh, maybe. Oh, yeah. Oh.
Yeah,
Maybe 37%. And then do it again and then get 1.
yes. Yes.
Well, I think it's just because my other classes suck. Like this one's
I got a 125th on the first one. Number 3.
How?
I don't know.
What did you divide by? Did you get 2 over 1,000?
Yes.
Okay, so what did you divide by?
I reduced it by dividing by 2.
Okay, so what's half of 1,000?
50. Oh, I thought it was 100. Oh,
You sometimes it's easy what I call those mistakes autopilot mistakes. Instead of actually stopping and thinking, oh, what's half of because you know a half of 1,000, like you could do that. Like if anybody just randomly walked up onto you on the street, you'd answer it. But if you kind of autopilot and aren't really thinking about what you're doing, then you get weird answers that kind of sound like they're close to right, but
Okay, but Sean, if someone came up to you and said, what's half of 1,000, they wouldn't know what half of 1,000 was. So not everybody knows what half of
unless they were just trying on one of those like shows where they're trying to show how dumb everybody is. Which half of those shows are stupid anyway, because when you're put on the spot, it's hard to remember stuff anyway. So you don't have to raise your hand.
But the second problem still
No, he's not.
over 3 over 2.
What?
Would it still be correct on problem 2 if it was 3 over 2?
No, because I want a mixed number. Always.
He did. That's true. So
I
yeah,
did it right.
except not.
Right, so we'll just yell at you when we have a question.
Yeah.
That's it.
Alright, Sean,
Yeah, and then in the rare moments when it gets too crazy, I quiet the seas and we figure out from there. It's worked for me for years. It's much more efficient than raising your hands, because somebody could sit there with their hand up and I could be teaching away over here and whatever else and not see them for like half an hour, and then they're stuck with their question. They don't, by the time I get to them, who the heck knows what their question was? Not them, because they've been zoning out thinking about whatever in that amount of time and trying to sort of kind of pay attention while trying to write and raise their hand and whatever else. So,
Until he does that a lot.
what a lot. What are you talking about? All right, so we're gonna shift some gears, just a titch, and we are going to write each fraction as a percent. Huh? If you're, I will warn you. I know most of y'all don't, read, but, but, if that was so rude of me, I'm sorry. If you do, it is a real. I don't know if y'all all knew this, but we're doing this stuff out of a textbook, and so oftentimes if you go back and look at the textbook, if you're struggling with the lesson, it can help you. So that's a good strategy. Now, if you either have been in the habit of doing that in the past or might in the future for this one, if you follow these examples for these type of problems as it's written in the book, it will only work for some problems. Sort of. So, on example 3 in the book, 3A and 3B, if it were me, I would not do it their way. I would do it the way I'm going to show you right now, which is the obvious way that any person with a sane mind would teach you. I don't know honestly, the way they teach you reminds me a lot of like in the 5th grade or 4th grade when they're starting to teach you about fractions. They teach you all these stupid 100 charts which are confusing as heck and are never as helpful as whoever writes those curriculums thinks they are. It reminds me of that. So here's what is this, example 5, right? Okay. So it is 1/4. Okay. So the way I'm going to teach you instead of what's in there is we're going to do it in basically a 2-step process. The first step is to convert it to a decimal. So how do we convert 1/4 to a decimal? I know you probably already know that 1/4 is 0.25, but how do we actually do that? Divide. That's right. So 4 into, because they're not always as easy as 1/4, right? And 1/4 is pretty simple. 1.0. Float the decimal, 0, and then, excuse me, 4 goes into 10 how many times? Twice. 2 times 4 is 8. We subtract. We get 2. Bring down the 0. 4 goes into 20. 5 times 20. We minus. We get 0. So it's 0.25, right? So that's how we actually do it. Because if we start, calculator mans, with a decimal, in order to convert that to a percent, all we have to do is move the decimal place over twice, which is the same thing as dividing by 100.
So it would be 25.
It'd be 25%.
Okay. That was rather simple.
Easy peasy lemon squeezy. Let's do another example. And let's have a pop quiz. 6/5. So we're going to do the same steps. We're going to do 5 into 6.0. 5 goes into 6. How many times? Once. 1 times 5 is 5. We subtract and get a 1, bring down the 0. 5 goes into, 5 goes into 10 how many times? 2 times. 2 times 5 is 10. We subtract that and we get 0. Make sure we float up our decimal place. So we've got 1.2. To convert that to a percent, we move the decimal over twice. It'd be 120%. That's right.
Whoa, so smart. So smart, guys.
In case you're curious, the way they teach it in the book is you try to figure out what times the denominator equals 100, and then you multiply the top and the bottom, and then it's the top and whatever else, which is fine. It just is not always easy to do in your head. and is confusing in my opinion. So. That's fine. Don't worry about it. Okay. GP number 5. Magical unicorns. Whoa, what did I do? Timmy the toolbox. Probably, I don't know. I may have just made it up for all I know. I don't know. 3/10, and then GP number 6.
I'm writing 6 instead of G.
Good for you.
I just
Did you say you think or you keep? Do. Ah. 7 halves. I don't feel like y'all know how to beatbox at all. Yeah, everybody knows that much. Okay, ready to go.
I'm going to slap you.
You do know that in order to do boots and cats, it's not just saying the words. Yeah, you're just kind of saying it weird though. Your cats works, but your boots doesn't have as much bass as it ought to. You gotta slap that B. You're welcome. I taught you something that wasn't math. I'm so lonely. Okay, so there's where we should have ended up.
What did you do?
I got number 6. I got the answer of number 6 on number 5.
You got 350% on number 5? I don't know how. How did you? Where'd like I could see you accidentally getting 300% by moving the decimal too much, but I don't know where the 5 came from.
I got 3.
Okay, that makes more sense. Yeah, you just need to move it twice, not 3 times.
The answer originally is 0.3, so then you move it over twice.
So this is where the work that should have existed.
Yeah, I see.
Okay. Aight.
So far, it's been my favorite lesson.
Favorite ever. On her science quiz.
Never mind. Delete that in me. I take that back.
It's probably an easy word problem.
Now we're entering writing class. I write more here than I do in my writing class. These problems. I don't write it all in my writing class. I keep it all in my brain and I write it home.
On her science quiz, let's see, what name did they pick? Let's pick something fun. Shaquisha. I've never met a Shaquisha. I did know something else more like that, but I can't think of what it is. I'm pretty sure that's not remotely how you would spell Shaquisha. That's probably Shaquisha, but whatever.
When your name is in a
Got
problem and people notice, it's like, yeah, I bought 60 watermelons.
14 questions correct. Oi.
I know someone's name who's Haya.
Out of 16. Right. Shacks. Grade as a percent.
Is this a GP or
96%.
what's your
Example. Doesn't say GP. But it is an example. Totally fine question. Totally fine question. What are we going to do?
Do we want to?
Yep. 14 over 16. And then we need to convert that to a percent. Sure, why not? What are you going to divide by? So 14 divided by 2 is 7. 16 divided by 2 is 8.
Then do we want to put 100 over it or under it?
Nathan, why did you bring some?
We're going to convert it. We're going to convert it to a decimal first.
Okay.
So 8 into 7. 8 goes into 70 how many times? 8 times 8 is
64.
64. So 70 minus 64 is 60. 8 goes into 60 how many times? 7 times. Yep. This gives us 56. Sixty minus 56 is 4. 8 goes into 40 how many times?
3?
5.
Oh, wait.
5 times.
That means
And then do we move, since we have that, do we move the decimal over twice? And it is
What?
Sean, your face.
It's just their check for reasonableness is really stupid, but that's fine. So 0.875. We need to now convert to a percent. So what are we going to do? Move the decimal twice. She made an 87.5%.
Is that how you grade ours?
Yes, but the questions I give you is almost never just 1 point apiece.
Yeah. It's because you give us points for like.
Yeah. So a question might be 7 points, 8 points, whatever.
If you want to send me a picture of it.
Somebody's stressing a little bit. If I think about it, I will. Any questions on that problem?
No, sir.
Is the notes more?
No, because of the way this program is working, I'm afraid if I add a note, it'll take even longer to open the stupid file again next time, and so I'm just not adding them. I know, it just makes you sad.
You could have made it yellow.
I know, but I don't usually use gray as a normal color, so I'm using gray as your homework, because homework is so gray and gloomy.
Yeah.
Because I love you enough to cause you helpful pain. Homework is on page 338. And you're doing numbers 12 through 36. Y'all are going to love 36. 36 evens. I really like 36. It's a great problem. It is not listed as a hot problem, but y'all might think it's kind of hot. So I did mean to write evens. Yeah, 36 is a nice problem. It's a good one. You're going to love it.
I'm trusting you.
It's, I will tell you right now, it's going to take multiple steps to complete.
How exciting. Nice.
And you might have to remember how to calculate the area of a rectangle. Just maybe.